At 6:15 local time, a group of 15 Ukrainian drones raced across the Gulf of Finland toward Luga, Russia's largest Baltic port, so heavily defended the Russians called it untouchable. After flying 960 kilometers through the night, engines running hot, fuel gauges dropping toward empty, everything seemed normal until a Russian patrol materialized through the morning fog. The formation leader suddenly jerked hard right as tracers erupted from below. The Russian patrol boat had spotted them, its 14.5 millimeters machine gun walking fire across their flight path. The rounds passed between two drones close enough that pilots would have felt the pressure waves. But these had no pilots, just operators watching grainy satellite feeds from bunkers near Kiev. 3 missiles launched from the patrol boat, Igla-S missiles meant for helicopters, now desperately fired at shadows in the dawn light. The drones scattered like starlit birds, some climbing, others diving to wave height. One missile lost lock completely, spiraling into the Baltic. Another exploded harmlessly between targets. Its proximity fuse triggered by empty air. The third found its mark, turning the trailing Beaver into a brief fireball that scattered across the water. 14 survivors regrouped and pressed on towards Luga, now just 40 kilometers ahead. That's when the S-400 battery lit them up. The S-400's gravestone radar has been tracking them for minutes, but only now revealed itself. Switching from search to targeting mode, these weren't commercial drones. These were UJ-26 Beavers, purpose-built weapons that could eat even Russia's most advanced SAMs for breakfast and ask for seconds. The Russian radar operator was about to learn why his trillion rubble air defense system feared these $35,000 drones as soon as the Beavers got within range. The S-400 began painting them with radar energy. The S-400 works by shooting a focused radar beam at 3 GHz, measuring how the signal bounces back. Think of it like sonar, but with radio waves instead of sound. The problem is that these Beavers were made of fiberglass and carbon fiber materials that only reflect 10% of radar energy compared to metal aircraft. At 40 kilometers, they look smaller than seagulls on the screen. The operator couldn't get a solid lock. So he tried something clever. Track via missile fire first. Use the missile's own seeker to relay better targeting data back to the battery. 2 48N6 DM missiles erupted from their launchers, each worth $2 million, designed to destroy Hun 000 million fighter jets. But here's where physics became Ukraine's ally. The drones immediately dove to 10 meters above the Baltic waves. The missiles tried to follow, diving at 70 degrees, but their control fins work like airplane wings. They need airflow to steer. At that steep angle, the fins stalled, sending both missiles tumbling into the water. The S-400 crew switched tactics, launching 9M96E2 missiles equipped with gas dynamic thrusters, tiny rocket engines that fire sideways, allowing 90-degree turns even without airflow. These missiles were different. They could pull 60 Gs, turn on a dime, and chase targets down to wave height. The lead Beaver tried to evade, banking hard left, but the missile computed the intercept point and adjusted. 3 seconds to impact. 2 seconds, the warhead detonated, sending 200 tungsten fragments through the air. The drone disintegrated into carbon fiber confetti. A second missile found another target, but the debris created an unexpected problem. 13 radar returns became hundreds as wreckage scattered across the sky, masking the survivors. The remaining 13 drones scattered like a bunch of rabbits avoiding a hawk. Some climbed, some dove, some went left, others right. But Russian air defenders had seen this before in previous encounters. They'd already positioned 4 Painter systems in overlapping fields of fire, creating what they called a box. No matter which way the drones flew, they'd enter someone's engagement zone. The Panthers were specifically designed for this threat, combining missiles for long range and cannons for close-in defense. Think of them as the goalkeeper. In soccer, the last line when everything else fails. Each Painter uses a different engagement philosophy than the S-400. Instead of firing multiple missiles at once, they use shoot, look, shoot. Fire one missile, see if it hits, adjust, fire again. This maximizes accuracy against maneuvering targets. The first Pantsir locked onto these drones flying in formation, launching a 57E6 missile at the leader. The drones immediately executed a wagon wheel maneuver, spiraling around a common center point while maintaining forward momentum. Imagine riders on a carousel that's also moving forward. The constantly changing aspect angle confused the missile's proportional navigation system, which predicts where to intercept based on consistent target motion. The Pantsir gunner switched to his twin-barrel 30mm cannons capable of firing 5,000 rounds per minute. Instead of trying to track individual drones, he created a beaten zone, filling a cube of airspace with so much lead that anything passing through would get hit. 4 drones entered this zone. 2 emerged on the other side. The math was brutal but simple. 9 drones remaining, almost a dozen Russian missiles and hundreds of cannon rounds expended, and they hadn't even reached the port yet. Meanwhile, warning lights illuminated across Leningrad Oblast Command Center, showing similar battles going on at Kursk, Bryansk, and Rostov. 14 other drone groups were attacking simultaneously across western Russia. Every air defense battery was engaged. There would be no reinforcements. The Russians here were on their own, but so were the drones. The surviving drones pressed on toward their target, knowing the hardest part was still ahead. The Kasuka-4 electronic warfare vehicle you see here looks like a shipping container on wheels, but inside was $20 million of jamming equipment. As the 9 surviving drones approached Ust Luga, the system activated, flooding the electromagnetic spectrum with interference. The Kasuka works by overwhelming radio frequencies with noise. Imagine trying to have a phone conversation while someone blasts static through a megaphone next to your ear. It swept from 1.2 to 5.8 GHz, hunting for the control frequencies linking the drones to their operators 1,000 kilometers away in Ukraine. The Russian EU operators used a technique called sweep and dwell, rapidly scanning the spectrum to find active signals, then concentrating all jamming power on those specific frequencies. Within seconds, they identified transmissions at 2.4% Jas. The Kuka focused its 20W beam, creating a wall of electromagnetic noise, but the Beavers weren't using simple remote control. They were frequency hopping, jumping between 128 different channels per second in a pseudo-random pattern. Think of it like constantly changing phone numbers mid-con conversation with just one person, knowing the sequence in advance. In theory, it should be impossible to jam, but the Russians had something else they could try. The Russians countered with barrage jamming, flooding the entire spectrum regardless of specific frequency. The concept in theory is simple. If you can't find the needle in the haystack, set the whole haystack on fire. This should have severed the control link completely, but the drones kept flying. They'd switched to autonomous mode using terrain contour matching, comparing radar altimeter readings to preloaded topographic maps. Every hill, every building, every bridge had been mapped and programmed. The drones knew exactly where they were without any external signals, but autonomy created its own problems. 3 drones flew directly into a construction crane that hadn't existed when their maps were programmed. 6 months ago, the metal tower appeared suddenly in the fog, too late to avoid. The impacts were instantaneous. Carbon fiber versus steel never ends well for the drone. 6 survivors continued, but their battery showed 18% remaining. The calculations became critical, enough power to reach the target, but none for evasive maneuvers on the way in. They only had 1 shot at this. Meanwhile, the S-400 battery commander faced an impossible decision. His remaining missiles cost $2 million each, designed to destroy aircraft worth $100 times that the drones attacking his sector cost $35,000 each. Even if he destroyed every single one, Russia would lose financially. This wasn't warfare. It was economics with explosives. The commander ordered his men to switch to Zu-23 anti-aircraft guns, these twin-barrel 23mm cannons dated from the 1960s, but the ammunition costs only $3 per pound. And besides, getting hit by one had the same effect. The problem was these old guns required optical targeting. Someone had to see the target to shoot it. The drones flew at 150 kilometers per hour, executing random barrel rolls every 2 to 4 seconds. The targeting computer needed 3 seconds of steady flight to calculate a firing solution. It never got it. The gunners resorted to World War II tactics, filling the sky with tracers and hoping something connected. One lucky burst caught a drone mid-roll, tearing through its fiberglass fuselage. 5 drones remaining, Ust Luga port just 8 kilometers ahead. But here's the thing about real war. Sometimes man-made weapons aren't the only thing you have to worry about. As the drones closed with the port, the rising temperature made the fog that was hanging low to the deck start rising. The fog that had saved them earlier now came back with a vengeance. It soon turned battlefield into a ghostly maze where million-dollar sensors became worthless. The fog cut visibility to 30 meters. The Russians couldn't see the drones. The drones couldn't see the port. Everyone was flying and fighting blind now. The Pantsir's thermal imager, designed to detect heat through smoke and darkness, could normally spot aircraft at 5 kilometers, but fog scatters infrared radiation just like it scatters visible light. Detection range dropped to 200 meters. The defenders switched to area saturation. Firing blind at the approaches they calculated the drones must use. They were creating walls of lead at specific GPS coordinates, betting the drones would fly through them. 5 Ukrainian drones descended to 3 meters above the Baltic waters, their radar altimeters pinging constantly to avoid crashing into the waves. Salt spray coated their camera lenses, turning any video feed into a useless blur. The operators in Ukraine, watching through satellite data links, saw only gray static. They were flying on GPS coordinates alone, trusting mathematics to guide them through the murky skies toward Luga's gas complex. Frustrated at a lack of hits, the Russians activated their GPS spoofing system, broadcasting false position signals from powerful transmitters. This technique works by overwhelming the weak satellite signals with stronger fake ones, making GPS receivers think they're somewhere else entirely. Imagine your car's navigation suddenly telling you that you're driving through a different city. 2 drones following spoof coordinates banked hard right and flew directly into the water. The splash was invisible in the fog, just brief radar returns that vanished. 3 drones remain. Their backup inertial navigation systems keeping them on course despite the GPS lies. Port security forces armed with Igla-S shoulder-fired missiles waited on rooftops and towers. The Igla Seeker uses a nitrogen-cooled detector that sees heat at wavelengths between 3 and 5 microns. Human eyes see at 4 to 7 microns. The Igla sees deeper into infrared, detecting temperature differences as small as half a degree, but the Beaver's tiny 20-horsepower engine ran only 40 degrees above ambient temperature against the warm Baltic fog. It was nearly invisible. The troops fired ambush shots, waiting until they heard drones pass overhead, then shooting from behind where the exhaust heat was strongest. One missile found its mark. The proximity fuse detonating 5 meters from a drone. Shrapnel tore through composite skin and control cables. The drone spiraled down into a storage tank farm. 2 survivors pressed on, weaving between 40 meters tall petroleum tanks. An Mi-8 helicopter thundered overhead, door gunners firing PKM machine guns at shadows in the fog. The helicopter pilot tried using rotor downwash to blow drones into obstacles, 60 kilometers perf winds that could slam them into tank walls. But the downwash also cleared patches of fog, temporarily improving drones' cameras. So for brief moments, the operators could see their target, the massive cryogenic processing complex ahead. The facility's automatic safety systems detected uncommanded aircraft approaching. Threat assessment algorithms, usually designed to prevent accidental airplane strikes, triggered emergency protocols. Warning sirens wailed across the complex. Emergency venting began, releasing thousands of cubic meters of methane and ethane to prevent catastrophic overpressure if the tanks were breached. The invisible cloud of flammable gas expanded across the facility, waiting for any spark to turn it into a massive fuel-air explosive. The defenders had inadvertently created the perfect conditions for maximum destruction. Water cannon trucks raced to intercept points, their operators trying to knock drones down with high-pressure streams. These weren't your backyard super sowers, but industrial equipment that could punch through wooden walls at 50 meters. One drone flew directly into a water column. The pressure snapping its propeller like a twig, it tumbled onto concrete. Warhead intact, but harmless. The final Beaver adjusted its course, its thermal camera finally locking onto the unmistakable signature of the cryogenic processor, minus 160, 3 degrees Celsius, colder than anything else on the board. The operator switched to manual control via Iridium satellite link, accepting the 2-second delay that made precise flying nearly impossible at this distance. The drone had 12% battery life remaining, enough for maybe 90 seconds of flight. It traced a weaving path through the maze of pipes and towers, each turn burning precious power. Security forces fired rifles and shotguns at the sound of its motor, bullets sparking off metal infrastructure. One plet cluster shattered the camera, leaving the operator flying on last known position and dead reckoning. 10 seconds to impact, 5 seconds. The battery level hit critical, motors beginning to lose power, but momentum would carry it the final distance. The last Beaver drone struggled through the refinery's 3-dimensional maze of pipes, towers, and catwalks. Its civilian GPS receiver, accurate to 5 meters on a good day, showed position errors of 30 meters due to multiath interference. Signals bouncing off metal structures created false readings, as well as the GPS spoofing that was getting stronger. The operator in Ukraine, watching through a 2-kilobit Iridium satellite connection, saw only basic telemetry, altitude 3 meters, speed 40 kmh, battery 8%, target bearing 285 degree, no video, no radar, just numbers updating every 2 seconds. As the drone flew toward its program coordinates, the 2Com control lag made precision impossible. When the operator commanded left, the drone had already traveled 20 meters before receiving the signal. He had to fly by prediction, imagining where the drone would be, not where it was. Like playing a video game where the screen shows what happened 2 seconds ago. Through the static, he caught glimpses from the failing camera, a massive cylindrical tower, pipes wrapped in silver insulation, warning signs in Cyrillic, the cryogenic fractionation unit, the heart of the complex where gas condensate was separated into valuable components. Security teams deployed their last-ditch defense. More water cannons mounted on trucks. One cannon tracked the drone sound, its operator leading the target like a hunter shooting clay pigeons. The water jet caught the Beaver's tail, spinning it violently. The drone's gyroscope fought to stabilize, motors screaming at maximum power, draining the last reserves. Battery warning 5%. The operator knew he had one chance. He pushed the nose down, converting altitude to speed, diving toward the base of the target. Emergency venting had created an invisible cloud of methane mixed with ethane and propane. A perfect fuel mixture waiting for ignition. The drone's 20 kilograms warhead contained thermite-enhanced charges, aluminum powder, and iron oxide that burns at 2,500 degrees Celsius. Thermite can't be extinguished with water or foam. Once it starts, it burns until the fuel is consumed, hot enough to melt through steel in seconds. The warhead was set for impact detonation, a simple mechanical trigger that needed no electronics. 3 seconds to impact, the battery died completely, motors stopping instantly. But physics took over. 40 kilograms of drone traveling at 15 meters carries substantial momentum. It glided the final 50 meters in eerie silence, a ballistic projectile following Newton's laws. Security forces held their breath, hoping it would miss, fall short, hit something non-critical. The drone struck the fractionation column's base exactly where the operator had aimed, crumpling against steel with a metallic crunch. For a heartbeat, nothing happened. Then the thermite ignited. The initial explosion was small, just a white, hot flare that burned through the column steel wall in 2 seconds. Superheated metal sprayed into the pressurized vessel, instantly vaporizing liquid hydrocarbons. The pressure spike ruptured adjacent pipes, releasing more flammable gas. Then the vented cloud ignited. The fuel-air explosion expanded at 3,000 meters S, a crushing overpressure wave that shattered every window within a kilometer. The fireball rose 200 meters, brilliant orange against the morning fog, but this was just the beginning. The facility suffered a BLEVE boiling liquid expanding vapor explosion. When pressurized liquid gas suddenly depressurizes, it expands 600 times in volume. Creating devastating explosive force, each ruptured vessel caused adjacent vessels to fail, a cascade of destruction that consumed the entire complex in minutes. The $2 billion cryogenic processor, designed to withstand earthquakes and storms, collapsed into twisted metal. The fire would burn for 6 days. Visible from satellites from the Estonian border, a pillar of smoke marking Ukraine's deepest strike yet. Bye for now. If you like this video, please share it, subscribe to the channel, and don't forget to leave your feedback in the comments.